The purpose of this video is to review how to program and to offer some basic troubleshooting advice on a control board made by Capital Vending. This control board with the white printing on the case is designed for a 3-hopper dollar bill changer, so this would go back all the way to BC9, BC20, BC35, and BC3500. The control board is the same for all of these kits. The difference is the harnessing that we provide to you is different based on the cabinet that the board is installed in. First step I'm going to kind of talk about is how we set our dip switches on the dollar bill validators. And this board will process 1 through 20s depending on the model of the bill validator installed, or throughout the life of this board if you need to change the dollar bill validator. Just remember, this is a good reference. This tells you which switches to put into the on and off position so that the bill validator will work properly. This control board is, when it's active, it will only turn on what I would call the count emitters on the payout assembly when they need to be on. So very typical on a Rowe machine, they would always burn the 755 bulbs or the LEDs. So when this is installed, it's completely normal that those LEDs are not turned on until it actually accepts money and processes it. Once it accepts money, we have 3 little green LEDs here for the left, center, and right hopper, so those will illuminate when the hopper is supposed to be dispensing coins. In the event that you put money in and it goes to dispense coins and these lights come on, but it does not pay out money, next to this replaceable fuse there's a little Pica fuse that's soldered in here, and that controls the 120 volts. If that happens, you would most likely have a short on the payout assembly, so I would do a lot of troubleshooting and find the short circuit, because that's that fuse can handle a lot of current. So that would be some troubleshooting you could do. The other fuse on this board right here is a little 20 millimeter fuse. It's commonly available at any auto parts store. It's a very common fuse if you just ask for a 20 millimeter. And if that goes out, that's the primary power supply coming in. That typically would blow if somebody pinched the power cord of the machine, or if a coin falls back on the payout assembly. So now I'm going to talk about how we do our programming. With this board, you could program just 1 hopper to payout, and this is very helpful in the troubleshooting. Very often people buy our control board and they install it in the cabinet, and their motivation was to put this board in the cabinet. However, the reason they took out the old board and there was an issue with the payout assembly, either the motor's not working or the emitter and detector is not working. So once you put this in, if you do have issues, what we'll have you do is program and have the coins pay out at a 1 hopper at a time. Or perhaps if you install this in a couple of years, you're getting status codes for overpay or timeout. What you want to do is just use 1 hopper at a time to test it. So I'm going to talk about that now. These switches right here for the left hopper, the center hopper, and the right hopper. And what I'm going to do just for this video, I'm going to go ahead and turn all these switches to the left, which is basically turning all the payouts off. The value of the switches is printed right here. So it's 1, 2, 4, or 8, 1, 2, 4, 8, and 16. These top 4 position dip switch banks correspond to the $1 payout. So when $1 is accepted, the value of the coins that are turned on for the left, center, and the right are dispensed. So what I'm going to do, just for troubleshooting and to kind of simplify how this programming is done, if I turn dip switch number 3 on for this right hopper, dip switch number 3 is 4 coins. So that would be when $1 is inserted, this is going to give you 4 coins. The bottom bank is for $5, which is doubled and quadrupled when a 10 or 20 are put in the machine. But for now, just for troubleshooting, for instance, I'm just going to leave that off, so I'm only using this. So what we could do is put a $1 bill into the bill acceptor, and we want to get 4 coins without any status code problems. Other tricks we have here, we have our reset button that is pressed in the event you ever get a failure, a status code failure, which I'll review. This switch right here, if you do this with a pencil eraser, if you touch this $1 quickly, it basically simulates one pulse coming in from a validator. So for whatever is programmed here, you'll get $1 payout. And that kind of saves time. The other issue is if you don't know if your harness to the validator is bad or your validator is bad, what I do is I disconnect the harness that goes to the validator, which is on this connector, and I could press this 1, and if I get the $1 payout, then I basically know the capital vending control board is working. So in the event that I program it this way and the control board works perfect, then what I would do is turn the board off, which is this switch to the right. I'm going to go ahead and disable this. So right now, by moving switch 3 here, I'm telling it no coins are going to be dispensed. If I want to, I could put, just to kind of give you guys some variance, I'm going to put switch 4 on for the center hopper. So for each $1 value installed, I'm getting 8 coins coming out. So I'll turn this board on. Just as a habit, I just always hit the reset button. So with it programmed this way, for each $1 value, you would get 8 coins. So I will put in a $1 bill in the validator, and then I'm supposed to get 8 coins from the center hopper. In the event that that works good, then I'm going to move on again to my left hopper and just troubleshoot that. So I would turn the board off. I'll turn that to the off position, and just to give you guys a different scenarios, I'm going to put switches 1 and 2 on. So that's going to be 1 coin plus 2 coins. So with 1 and 2 on, for $1, I'm going to get 3 coins, and since this is the only hopper programmed, I'm only going to get coins out of my left hopper. So I'll turn the board on, put $1 in the validator, and test and see that I do get 3 coins. The purpose of explaining this to you is to kind of help you troubleshoot the board, or just say that you just do one hopper at a time. In the event that you come to your board and this status light is blinking, the way you would clear it is hit reset. But before you do that, I want you to count how many times this red LED is blinking. And here we have our status codes. 1 blink would be hopper empty. That's typically very rare. The C8 container, when we ship out the board, we have a set of jumpers on here. This is used to monitor the level of the coin hoppers. Most of our customers don't use that. In a triple hopper machine, if you fill it with coins and have a Mars validator with a 1,000-note bill box, more typically the machine would stop accepting bills because it would be full of cash as opposed to running out of coins. But in the event that you do need to monitor the level of the coins in the hopper, that is an option. The 2 blink code is timeout. What that would mean is that the hopper ran for over 16 seconds without seeing a coin counted. So we kind of have that as an anti-jackpot in the software, that we don't want it to free vend in the event that an electronic part malfunctioned. But if your machine has a dirty hopper that's not working properly, this timeout is going to shut your machine down. So it's important that your machine is level. If you have clean hoppers, they're going to pay out coins rapidly. 3 blinks. If you get 3 blinks, you have an overpay. When you have an overpay situation, what's typically wrong is the clutch motor on one of the hopper motors is defective, so it's overpaid a coin. So when you get this overpay, sometimes that's actually hard to determine, but the easy way to do that is to go back here and program this board just to pay out of 1 hopper, so that, for instance, if you're having a hard time figuring out this overpay, what you would do is have it program out of 1 hopper, test it, and then if everything works perfect, you know that hopper's good, then you could add the next hopper to it, or turn these off and kind of go through right, center, left until you get it to malfunction. But if it's hard to determine if it's overpaying or if it's only doing it every once in a long while, what you want to do is, as I explained in the beginning of the video, only use 1 hopper to pay out the coins. 4 blinks is the most common call we get, is for security. And what that means is the emitter light, the 755 or the LED, is either burned out, is not bright enough to activate the detector, or the detector is bad. To troubleshoot a security problem, what you would do is take all 3 hoppers out of the machine, and then with the door open, because you want to watch what's happening, put $1 in, and then look and see which of the 3 lights is not coming on, or which is not bright enough. The other way, and then when you determine which one is defective, you could turn the corresponding hopper off while you're waiting to get the parts, The 4-blink security is the most common error we get, and what that means is that the emitter bulb is not working well. So depending on the age of your machine and if it's been updated, you want to look at the 755 or the LED in your machine. So you'll take out all 3 hoppers, and because this board doesn't illuminate the light, you'll have to put a dollar in like it's ready to vend, and then visually look and see which of the 3 lights is not coming on. In the event that all 3 lights come on, one of the detectors could be defective. 95% of the time it's the LED is not bright enough or the 755 bulb is burned out. We do recommend you replace that 755 bulb with one of our LED kits. But if you are getting this security and you can't see what's happening, go back to what I showed you in the original part of this video and try and just use 1 hopper at a time until you get the machine to fail. And that way you'll kind of take care of the security error. The other one is a 5 blinks, and that's in impossible values, and that has to do with how you're programming the dip switches here, and when we use what we call the hopper swapper, so that if one hopper gets empty, it moves over to the next one. So if there's a mathematical error in your programming, the board is not going to activate. So I'm going to move on in the next section of this video. We're going to cover how to do the real programming for your cache.